At the CoinGeek conference in Seoul, MoneyButton is announcing 4 new extensions to Paymail, all of which have to do with allowing users to own their data. So, the basic idea behind this is to change the internet from something where fundamentally many of the largest companies are funded by ads, which means basically recording user data and delivering targeted ads to you, towards a model where ads still exist, but they're only one of many different payment models where users fundamentally own their data first and foremost and can choose how they want to monetize their own data. So let's take a look at this video from Mark Zuckerberg first.
Welcome to F8. Today, we are going to talk about building a privacy-focused social platform. Privacy gives us the freedom to be ourselves. So it's no surprise that the fastest ways that we're all communicating online are private messaging, in small groups, and in stories. This is the next chapter.
The future is private. So it's very interesting that Facebook is actually moving in the direction that we want to go in. They actually understand, I think, some of the problems here, and they're moving towards a model where the users will have privacy. They're not there yet, and this isn't currently the case on Facebook, and we'll see whether they're able to fundamentally pivot their business into the future. But they do seem to at least be aware of the problem. We're trying to show here in this graphic, like, what would it look like if we had a peer-to-peer internet. So the idea of peer-to-peer is the idea that users can engage directly with one another rather than through a central intermediary like Facebook. So if we look at all of the social media networks in the world, this was as of 2018. Facebook is the largest, YouTube is the second largest, Instagram is the third largest. Instagram, of course, is owned by Facebook, and YouTube is owned by Google. So basically, Facebook and Google have a majority of the sort of the social engagement on the internet. And both of them work fundamentally the same way from a business perspective, which is that they know a lot about you based on the data that you're creating on these platforms. And they can then deliver targeted ads. So they work with third-party advertisers who can basically pick demographics to show ads to. This is just a chart of the revenue that Facebook has earned based on user geography around the world for ads. And these numbers, if you compare these to other businesses, I mean, Facebook is a huge company. It's one of the largest companies in the world. Same with Google. Google and Facebook both, because they both dominate the sort of online advertising space, are huge companies earning some of the largest revenues in the world based on this model. So it's working quite well for them. It doesn't work that well for many other advertisers. So a lot of the other smaller companies like newspapers and things like this don't have as much information about users and can't deliver targeted ads to the users quite as well as Google and Facebook. So Google and Facebook together have basically a sort of duopoly on the advertising space on the internet.
Thank you very much, Mr. Chairman. Mr. Zuckerberg, would you be comfortable sharing with us the name of the hotel you stayed in last night?
No.
If you've messaged anybody this week, would you share with us the names of the people you've messaged?
Senator, no, I would probably not choose to do that publicly here.
I think that might be what this is all about.
So this is when Mark Zuckerberg had to testify in front of Congress and basically explain to Congress why what they're doing isn't a problem. Because in the U.S. And globally, but in the U.S. specifically, because that's where Facebook is based, and the U.S. is trying to figure out how to regulate this sort of privacy problem around social media. Europe seems to have taken the lead on this and has this GDPR framework that Facebook complies with in Europe. That's an example of the type of regulation you might see coming through in the U.S. California has done something very similar. So California is the first state in the U.S. to sort of move in this direction of regulating basically the way that companies can use user data.
We're trying to use data and technology to make to allow campaigns to engage with voters in a more informed and relevant way. We do a lot more than that. I mean, deep digging is interesting, but equally effective can be just to go and speak to the incumbents and to offer them a deal that's too good to be true, and make sure that that's video recorded. These sorts of tactics are very effective. Instantly having video evidence of corruption, putting it on the internet, these sorts of things.
So this is just some clips of Cambridge Analytica, which was a company that used data to sort of allow politicians to deliver ads related to running for office to internet users. And so what Cambridge Analytica did that generated a lot of controversy was they misused data that they got from Facebook. And so this is really basically why Mark Zuckerberg was in front of Congress. Was Facebook hasn't always been responsible with respect to allowing people to access the data that they get from Facebook. And Cambridge Analytica was a company that really went to the maximum extent of abusing their privileged access to this data to deliver, basically fundamentally to know something about the users, to deliver misleading information to people. And there's not enough time in this presentation to cover everything, but it's very interesting if you look into the tactics that Cambridge Analytica uses and many of these companies use to not just deliver ads to you, but actually give you misleading information and try to manipulate you based on the information that they're able to gather from Facebook and from other sources. And Cambridge Analytica ultimately actually had to close down because they generated so much controversy it ended up killing their company. So they're basically the in a spectrum of sort of good to evil. They're way on the evil side of totally using this data wrongly. So they're basically the problem that we're trying to solve. So I don't place all of the blame on Facebook. Facebook seems to be at least stating publicly that they want to move in the correct direction, but there are many bad actors out there that are just ready to that are currently misusing and ready to misuse this data any which way they can. Okay, so here is a photo of some of the early members of DigiCash. DigiCash was the first sort of serious attempt to create a digital currency. It was founded by David Shum originally in the 80s. So cryptocurrency goes back actually quite a long ways before Bitcoin. DigiCash was the first. DigiCash did not succeed. They ultimately failed. But it's very interesting to consider the history of cryptocurrency very briefly because it actually has a lot to do with why the internet works the way that it does. So the history in a nutshell was in 1989, DigiCash launched. We had the first web browser in 1991. The internet was commercialized in 94. But DigiCash didn't succeed for a lot of reasons. And they went bankrupt in 1998. And Facebook launched in 2004. Bitcoin was 2009. So you can see the context in which Facebook was created was not one where we actually had digital currency available. And so Facebook, along with Google and many of these other companies on the internet, many of the other social media companies, used ads because digital currency was not an option. The technology that we now have with Bitcoin wasn't available at the time. Ads was basically the only way that something like Facebook could launch. And if you know the history of Facebook, this was created by Mark Zuckerberg and some other co-founders. And they just created a social network for Harvard students that grew out to college students and then to the entire world. But ads was the only thing they could really do. Now, it turned out to be a very good business model from Facebook's perspective, but the point is that micropayments or something like that wasn't even an option. There was no digital currency option at the time. So the idea here is to look towards the future. Facebook is launching their own digital currency called Libra. So Bitcoin is going to be a competitor to Facebook's Libra. So in the future, we're going to have, Facebook clearly recognizes the direction that this is going in, and that's why they're creating their own digital currency to fit into this picture as they see it somehow. I think we can help Facebook. I think that for a lot of reasons that wouldn't fit into this talk. I mean, I don't think that Libra will ultimately work out. I think they'll have to change it. I think the way we should look at this with Bitcoin is we can create the platform that Facebook itself can use to monetize content inside its platform, give users the tools that they need to fundamentally own their data at a technical, at an economic, at a legal perspective within their platform on Bitcoin. Because what we're doing is actually going to scale. It's actually going to work. And I think when they realize how far ahead we are at making this stuff actually work technically, that they would be willing to use it. And so I think we ought to adopt that stance that we're not really competing with Facebook. We should look at Facebook as a prospective customer of Bitcoin and of all of our various company services. Okay, so how can Bitcoin actually help with this problem? Fundamentally, Bitcoin allows you to own your data and your money, but we have to build a lot of stuff on top of this to actually make this work. So Bitcoin has a bunch of wonderful properties that can help with this idea. So for one thing, we have micropayments. We have the ability to send small amounts of money with very low fees across the internet. So this makes it possible to monetize small pieces of content like articles and images and things like this. The payments are instant. So when you're actually in the system, you don't have to wait for things like transferring from bank account to bank account or wires or anything like this. So the payments are instant. And for anybody that's used Money Button, you can see and feel exactly how instant it is. The payments are borderless. I mean, you have much less, difficulties with interbank protocols and things like this. I mean, you can Bitcoin is native to the internet, and there's nothing stopping you from sending it to people anywhere in the world. We can comply with all government regulations anywhere in the world. So compliance is a really important thing for people that want to create real businesses. This isn't about avoiding the law. It's about making sure that we actually can comply with the law everywhere. So the law is different in different countries, and we can comply with AML, KYC, and any other laws that we need to anywhere in the world. The payments are cash. So this has a lot of implications, but it means that things like the level of privacy is adjustable depending on circumstances. The default amount of regulation that you have to comply with is less in the case of cash. So that just makes it a bit easier. Smart contracts, we have all sorts of advanced features that we can build into the payments. So the ability to pay multiple people, multi-sig, the ability to pay taxes automatically. These are just some examples. This deserves a whole other talk, but there are many advanced things that we can do that are possible to do in a secure way at lower cost than what we can do with traditional payments. Payment channels is a whole other subject as well, but this is just the idea of basically having very fine-grained access to control who sees what money, how much the fees are, and things like this. So we have very, very good control over what we can do with this. I would say that basically anything that you can think of with money can be done very cheaply and efficiently with Bitcoin. What we aren't is high fraud and high cost. So this is a different way of looking at the fundamental distinguishing features of Bitcoin from the traditional payment system. The traditional payment system has a lot of fraud because it doesn't use cryptography. And so a lot of you have to worry about people committing fraud. I mean, that's my sort of Bitcoiners perspective at it, is that they don't use crypto, but I think that's true. That fundamentally the reason why they have a lot of fraud is they didn't really think through, or I shouldn't say they didn't think through. It wasn't possible in the history of banking to do this until fairly recently. We basically needed Bitcoin to solve the economics and the technical problems to make something like this actually work. And so they're basically just old. We need Bitcoin that combines thoughtful economics with cryptography to bring down the amount of fraud and to bring down the cost of something that is something that works on the internet. Now, Bitcoin is not just about money and finance. There's a whole other way of looking at what is Bitcoin that is important when you want to do this sort of user own your data philosophy. So Bitcoin allows you to store and to transmit information with some really wonderful properties. The information itself is immutable, which is actually a property that you want. It doesn't mean that the user experience doesn't let you edit anything ever. It just means that at a purely technical level, you don't have to worry about data being corrupted, for example. The data can be authenticated. We use cryptography. We can play with exactly how authenticated all of the data is. You can sign stuff and know who created something. You can do KYC with third-party verification and things like this, and know who created something, who the real author of something is. It's very fast, actually. If we use Bitcoin as a replacement for the internet, which it can be done, I've given this talked about this in other talks and things like this. One way to look at this is, because everything's addressed by hash, it's like if the internet itself were a CDN, it would be much, much, much faster than the way the internet is right now. There would be much less pointless data redundancy and data transfer, because everything can be distributed exactly according to what people need. It's cheaper. It actually would be cheaper for that reason. It would be cheaper than the internet at scale. It's ubiquitous. It's something where everyone has access to this everywhere, and it's sort of intelligently redundant depending on economics. So everything about this is actually an information storage and transfer system as well. It's not just money. In order to solve the problem of money, Bitcoin needed to also be an information system. Again, each one of these things are related to how this is distinguished from the internet. And it's actually very similar to money, that the level of fraud and the cost is actually lower on Bitcoin than it is with the internet. It's the same properties as with money. So for instance, there's less fraud on the information on Bitcoin because of the fact that everything's addressed by hash. So you can't give someone the wrong file, for example. So ultimately, it's the unification of information and money. So the word Bitcoin is actually very appropriately chosen, I think, and that's very much what it is. It's not just about money; it's information and money, bit and coin. So bit is this, a way of describing information, and coin is a type of money. It's really both of these things combined. Bitcoin is a way to unify information and money, and both of these properties are something that we'll use to create the own your data paradigm for the internet. So in the pre-internet era, basically the way things would work is, if Alice wanted to get some information from Bob, Alice would buy something from Bob, such as purchasing a book from Bob. Alice sends money to Bob. Bob gives back the book. In the Facebook era, things work in a very different way. Rather than Alice just buying information from Bob, Alice, or rather in the way the scenario would work, Bob has his information on Facebook, and Alice basically posts her information to Facebook, which is her sort of private information. Gets the information that she wants back from Bob, and advertisers are the ones actually paying Facebook to deliver targeted ads to Alice and Bob. And I think the graphic here is actually slightly backward. We should have the information flow looking different. But in any case, the point is that Alice and Bob don't transact peer-to-peer. That we have these sort of pointless third parties. Now, this isn't just Facebook. This is actually, how media works, how things like newspapers work. I'm creating a bit of a sort of simplification, say this is the Facebook era. But it is true. We could call this the media era, would be a different way of looking at it. But it's all these companies like Facebook being the most visible and sort of extreme example of this, whereby people aren't actually transacting peer-to-peer on Facebook. They're going through these third parties. And instead of being funded directly, instead of like just buying information directly from people, we have these other people using the information in peculiar ways to fund things. So the point of the own your information or own your data philosophy is to go back to the idea of peer-to-peer, information transfer. That the way we want this to work is Alice will just buy information from Bob. That's it. So that's the paradigm we want to restore. And so we're looking at this from a bit of a social media perspective, but you can look at it from a sort of information perspective. How do we monetize information? We want to make sure that the default idea is that you just pay for the information that you want. You can still give your information to people if you want to. It's not like we want to prevent something like Facebook from being possible. We want to make sure that every other option is enabled, that every peer-to-peer option is possible, that Alice can buy information directly from Bob. If you want to use Facebook the way it is, you still can, but we want to make sure that these other options are possible. Okay, so what is MoneyButton? MoneyButton is a simple payment system. I'll show you just a quick visual graphic here of a purchase with money button. So all it is a very easy way for users to make payments on the internet. And we also have many advanced features behind the scenes while making sure that the user experience continues to be as easy and as simple as possible for the users, as well as for the developers. So Money Button is something that's easy to pay from a consumer perspective. It's easy to install from a developer perspective. And we have many of the advanced features of Bitcoin built in. So you can send to many people at the same time. We have support for some of the smart contracts of Bitcoin. You can write data to the blockchain and return. We have an integrated OAuth API, so users can sign in without typing in a password into websites, and we have built-in currency conversion. So from a user perspective, it's very easy to use it, but we're trying to create all of the advanced features that businesses and developers need to basically integrate Bitcoin into websites and apps. So a protocol we've been pitching recently is something called Paymail. So we've been involved in creating this inter-wallet sort of Bitcoin protocol called Paymail. And the idea of this is that we want to solve the user experience problem of Bitcoin. We want to make it so that everyone can actually use this easily, and that includes wallet to wallet and wallet to exchange transfers. And we believe that Paymail is a fundamental solution to naming and querying that we can use to solve every problem related to really identity, really allowing people to own their own identity, which they then use to own their data on the blockchain. So the basic idea of Paymail is this is just a list of Bitcoin addresses. If you're familiar with Bitcoin, you have almost certainly had to copy and paste an address or scan a QR code or something like this with an address in there. And one of the key problems we're solving with Paymail is to just get rid of this from the user experience. That users should never have to see this random gibberish in their user experience ever. And we want to replace that with something that looks like email addresses. So alice@example.com, this is just what a Paymail looks like. So email addresses have the property that they're both human readable and machine readable simultaneously. So it gives us all the properties we're looking for in a new naming system for Bitcoin. So one way to look at what Paymail is, it is email plus Bitcoin. It is completely compatible with email and can bring new features to email. Basically things like a public key and endpoints and things like this, to add advanced features that allow the user to the user doesn't have to do anything complicated. They just keep using their identity as they're already using it, but they gain access to some of the features that we're creating, and I will talk about in this talk. Okay, so let's compare email directly to Paymail briefly. So email is used as a messaging system, that what we normally think of as email, so just sending someone an email. But it's also true that email has ended up becoming used as an identity system on the internet, that very often you log in with your email address into services. But it's a very primitive identity system. What we're doing with Paymail is basically extending this and making it much, much, much more advanced. And the idea is that the user won't necessarily notice that if they're using email with Google or Microsoft, we want them to be able to add support for this without actually changing the user experience. But we want to add in all of these features that you can't do with email currently. So this includes, obviously, payments, where the name Paymail comes from. We can thank Alex Appiget for coming up with the wonderful name for what the protocol is. But of course, payments, you can easily pay from Paymail to Paymail. But we're adding in lots of other features: signatures, the ability to sign something with your Paymail, the ability to encrypt something, the ability to advance contracts on Bitcoin, as well as just overall extensibility, the ability to add any new feature that we can think of that we need for an identity and an authentication system on Bitcoin. So what we're happy to announce today is 4 new extensions to Paymail that we've developed for Money Button. We are announcing them today. We will be rolling them out in the next week or two. And all of the new extensions we've created are protocols. They're extensions to Paymail that allow the user to own their data. They're like fundamental pieces to the puzzle to take all the next steps to allow users to own their data. And all of our source code will be open source for all these things. So the things that we're adding are, first of all, peer-to-peer transactions, the ability for users to send transactions themselves directly peer-to-peer from Paymail to Paymail, the ability to sign data inside or outside of a Bitcoin transaction with a button swipe. So currently, when you swipe the button, you sign a transaction. Now you can sign other data inside the transaction. We're adding in encryption. You'll be able to encrypt data inside or outside of a Bitcoin transaction using Paymail, as well as a wonderful addition sort of to the user experience of Paymail, which is avatars and names. So I'll explain what all these things are in detail. So first of all, let's consider payments. We want to be able to send payments peer-to-peer. So from Alice to Bob, we want the ability to send the actual transaction itself directly peer-to-peer. So it's worth reminding ourselves that the title of the Bitcoin white paper is a peer-to-peer electronic cash system. For various reasons, wallets don't actually operate technically this way right now. In order to scale the system, we're going to need to move to a model where the transactions themselves are literally delivered peer-to-peer. I think we should interpret this literally, that Alice actually gives her transaction to Bob rather than broadcast it to the miners. And this is what we're building in. So here's an example of sort of the way that wallets currently work. When Alice wants to pay Bob, rather than give Bob a transaction, she gives the transaction to the miners, and then Bob has to then look at all of the transactions on the network to find the one that's for him. And the way Bob normally does this is actually to have a service do it on his behalf, of course. But the point is that we want to switch to a model where when Alice pays Bob, Alice just gives her transaction directly to Bob, and then Bob gives a transaction to miners. This removes a bunch of pointless work that's being done by Bitcoin wallets and by the network right now. This is what a peer-to-peer transaction looks like. Alice delivers the transaction peer-to-peer to Bob. It's just simpler, and it's literally peer-to-peer. What more can I say about it? It allows us to scale the wallets, and it's more user-friendly. So the next thing we want to do is the ability to actually sign data, that a user can publish their data to the blockchain and get credit for it, as well as have people be able to follow them and things like this on the blockchain. We need signatures. It's like a foundational piece that we need for all this stuff to work. So what we've done is to allow people to sign data with their Paymail inside of a transaction or off-chain, although I think the most important use case is going to be on-chain. That just means inside of your op return data. Like, let's say that you're writing an image to the blockchain. You can sign it with your Paymail. So Alice at example.com can publish an image, say, that everyone will be able to verify was indeed published by Alice at example.com. So the new protocol we've created is compatible with the author identity protocol. We wanted to make sure that we're compatible with all the protocols that people are currently using. We can also extend this to support legal contracts. I think it will almost certainly be used for social media right off the bat. But it is it's general in the sense that there's nothing stopping us from using this for legal contracts, so long as we create the sort of appropriate software to make it consistent with the law on that front. The next thing we've done is to allow Paymail, encryption with Paymail. So the ability to encrypt data for oneself or for other people. Again, either inside of a transaction or outside. So the basic idea of this is very simple. Alice might want to encrypt data for herself. So for instance, you might have wallet metadata or a document. Perhaps you're editing a document privately, like just any old file, like an essay or something like this. You should be able to do things like write the document and save it to the blockchain and update it privately so that you can recover your data on the blockchain. It's not being trusted to any third party. It's something that is, control, sort of living inside of this distributed network, which is the blockchain, that you can recover at any later time. So encrypting data for yourself. You should also be able to give data to other people. So being able to encrypt data to another person. And all this is based on Paymail. So it'd be like Alice at example.com saves her data to the blockchain, or Alice at example.com sends encrypted data to Bob at wallet.com so that only Bob can decrypt the data. So it's sort of like a fundamental piece. You need signatures and encryption to start building other users own their data technology on top of these things. So these are the basic properties of an own your data paradigm. So you need to be able to sign data. Signing allows you to have authentication. This allows you to know who created something, when they created it, who owns it, and what. Encryption allows you to fine-tune the privacy and access and control over that data. So signatures and encryption are foundational elements. We need new protocols on top of this. So for instance, we'll need a following protocol. This is a way for someone to, say, follow someone that they want updates from. A following protocol can be built on top of the signature protocol, for example, or a paywall protocol or anything like this, purchasing protocols. But signatures and encryption are the foundational elements. We definitely need signatures and encryption to build all of the next stages. So they're useful in and of themselves for these reasons. Okay, the final thing is Paymail avatars. This is just a way to make Paymails a lot more visual. It's something that we're already familiar with inside Google, that if you edit a Google Doc with other people, that they show the avatar and name of the people that you're editing the document with. We need something like this that's a generic protocol for the blockchain. So something where the users can see visually who else they're interacting with. So it's a very simple idea. It's the idea of attaching an avatar and a name to a Paymail so that inside of different wallets, you'll be able to see, like let's suppose you're sending from Money Button to Handcash or something like this. You can see the photo and the name of the person that you are sending money to, so that it's not just a name. It looks like a contact card where it's just visual and friendly rather than simply being a name. And it is compatible with Gravatar. And again, it's the way to think about it is it's just like you've already used this with Google, but instead of being a proprietary system for Google, it is something that anyone can use. Okay, so in conclusion, what we're trying to do is, make a user own your data paradigm something that exists and is something that's actually user friendly, so that we can start doing this right now. So the philosophy is about, we have this sort of legacy internet, companies like Facebook and Google that are monetized based on having lots of data about their users and then allowing third-party advertisers to deliver targeted ads to demographics based on that data. And they did it this way. I mean, it does work, but the real reason why they did it this way is that something like Bitcoin did not exist, and it was really the only way in the early 2000s when companies like this could actually monetize. Now there's a new option, which is Bitcoin. We have the ability to create a users own their data paradigm now. We have the founding protocol there. We have the ability to integrate money with information and properly allow users to transact directly with one another with no intermediary. And we can bring about this new paradigm without relying on having to give away all of our data to these data custodians. And so what we've done is to create Paymail, that was earlier this year, but also to extend Paymail with all of these basic features that we need that allow you to sign data, encrypt data, make payments and all this stuff on Bitcoin. So it's just additional protocols on top of Bitcoin. Bitcoin is the founding layer, but we're just building the next layer protocols that we need to use Bitcoin to allow users to actually properly own their data. And so the whole thesis of what we're doing is, because everything's based on Bitcoin, what we're really doing is we're solving the user experience problem for Bitcoin. We're not changing Bitcoin at all. Everything is based on the protocol as Bitcoin is already, but we're just making it so that you can just do these things easily, that the end user can sign and encrypt stuff without having to think about it or really understand what's going on. And the developers can build applications that build in signatures and encryptions and avatars and peer-to-peer payments without having to rebuild all of this infrastructure from scratch. Okay, so that's all I have to say. Thank you very much for listening to this talk. As I said, as of this recording of this talk, we're going to be rolling out these new features in the next couple of weeks. And so thank you very much for listening to this presentation. And if you have any questions or anything like that, please visit our Telegram group, t.me/moneybuttonhelp, or visit our documentation at docs.moneybutton.com. Or, of course, please just visit us at moneybutton.com. And that's all I have to say. All right. Thank you for listening.